Basic concepts of steel detailing. Introduction of structural steel detailing and training program. In construction industry, structural steel has become indispensable material. Steel has been most widely used material across the globe and considered as most reliable for the construction of structures of various shapes, sizes, and complexity. Be it a small individual house or a skyscraper or a state-of-the-art airport or an extensively long bridge or a huge stadium, steel helps to transform architects' imagination into reality. This is very small briefing about detailer. Steel 2D detailing means to provide drawing with dimensions as shown in left side snap, where we need to provide exact dimensions for element, where cuts and holes or any attached part with element need to locate in the member. It has to be shown in two-dimensional drawing. Who work-face these drawings? We called him as a detailer. In modern age, with the help of computers, various softwares and automation, process of steel detailing has been getting advanced day by day. Let us understand that, although computers and softwares assist in carrying out critical tasks of steel detailing, these are operated by steel detailer whose knowledge, skill, and expertise is the key to the process. Only way to develop such skilled and expert detailers is by imparting effective training to them. Even in computer age, importance of individuals' knowledge and skill is irreplaceable. Effective training followed by right application of knowledge on live projects will create such experts in the field of steel detailing. We are here to make such training program available for fresh candidates aspiring to be part of steel industry. Also, we would like to assure that this training program will give an opportunity for experienced steel detailers to further refine their knowledge and take their proficiency to next level. In today's extremely competitive world, every organization is looking for most skilled resources available in the industry and various ways of increasing productivity and quality. The competition will only further intensify in future, and organizations will need every help which can increase efficiency, productivity, quality, and in turn, profitability. Training program will deliver 1. Increased knowledge. 2. Better efficiency. 3. Enhanced quality. 4th, better productivity. 5. Value management. 6th, strong team development. Structural steel industry processes. 1. Design owner decides what type of structure is needed to be built, depending on its purpose to be served, expected utility. Owner approaches architect with his ideas and discusses regarding utility of the building, basic shape and size of the structure. He may also discuss about expected internal and external appearance. In other words, owner shares his dream with architect and initiates a process of turning his dream into reality. Architect imaginatively creates layout of the structure. He prepares a set of plans and elevations with specific dimensions. He defines specifications to show all the salient features of the structure, including interior and exterior materials to be used and its appearance. Once design approved by the owner, structural engineer is appointed for steel design. Structural engineer designs the supporting structure. He considers various loading criteria with load values defined by industry standards codes and as per the location of structure. Based on the structural analysis done using one of the software, he determines forces in the framing members of the structure and accordingly finalizes sizing of these members to resist anticipated forces as per his analysis. He then prepares a set of structural drawings showing structural plans and elevations with various member sizes defined, typical and specific sections, various specific details describing precise framing and connection requirements, etc. 2. Detailing. Preparation of shop drawings for a steel fabricator is called steel detailing, and the person who does it is known as a steel detailer. Steel detailer uses the set of design drawings prepared by structural engineer and creates shop drawing for each and every member of the structure. Detailer also prepares erection drawings for erector. In other words, the steel detailer transforms design data into drawing/material information required by fabricator and erector to build the structure. 3. Fabrication. steel fabricator accurately fabricates each and every member or element of the structure with the help of shop drawings prepared by steel detailer. 4. Shipping. Once the fabrication is done, steel fabricator needs to ship the material to the job site on time as per construction schedule. 5. Erection. After receiving fabricated material on site, erector erects each member with the help of erection drawings prepared by steel detailer. Erector needs to make sure that the structure is precisely plumbed and aligned, and also ensure that all joints fit properly as per structural design specification. Advantages of steel structures and types of steel structures. Advantages. 1. Design flexibility and strength. Steel as a construction material is light but strong enough and flexible to be used for building any kind of structure. It is produced in a wide range of shapes, which permits a lot of flexibility in design. It is uniform in quality and dimensionally stable. This encourages architect and engineer to imagine something unimaginable and bring it into reality for the world to get astonished. 2. Durable. Steel is durable and its durability is unaffected by alternate freezing and thawing. 3. Economical. Steel is relatively more economical. 4. Rapid construction and buildable in any season. With precise fabrication, steel structures can be built faster than other materials and in any season, weather. 5. Relatively easy to alter the structure. Steel also allows existing structures to be altered or expanded. 6. Easy field repairs. Field repairs are easier and faster with steel as compared to other materials. 7. 100% recyclable. Use of steel as construction material also helps in preserving the earth since it is 100% recyclable and it can be used again after strengthened process, and again without losing any of its original strength and other qualities. Vinay Add Steel Recyclable Process Video. Types of structures. Steel is used for the construction of various types of bridges and various types of utility buildings, structures. We may divide these utility structures broadly into 4 main categories: residential, industrial, commercial, and special purpose structures. Residential structures. 1. Residential buildings. 2. Individual houses, bungalows. 3. Apartments. 4. Condominiums. Industrial structures. Heavy manufacturing facilities, manufacturing steel, cement, automobiles, etc. 2. Light manufacturing facilities, manufacturing fans, water pumps, processed food, gadgets, etc. 3. Power plants. 4. Warehouses. 5. Data centers or telecom centers. 6. Research and development centers. 7. Cold storage buildings. 8. Flex buildings. 9. Showroom buildings. Commercial structures. 1. Malls and shopping centers. 2. Office buildings. 3. Hotels and restaurants. 4. Hospitals and medical centers. 5. Convention centers. Special purpose structures. 1. Airports. 2. Metros. 3. Stadiums and sports complexes. 4. Schools and colleges. 5. Museums. 6. Casinos. 7. Churches. Steel industry flowchart. This is steel industry flowchart for your understanding. Role and importance of steel detailers. For the successful and timely completion of any steel construction, it is very essential that steel members are precisely fabricated in the shop. Fabrication process consists of cutting, coping, drilling, welding operations, which must be done to absolute precision. Every bolt in the structure needs to fit perfectly on site. Also, erector should get all relevant information on erection drawings. This all will make sure that erection goes on uninterrupted and structure gets erected in time, with all the members perfectly fitting together and with all design requirements precisely fulfilled. To accomplish this formidable task, detailing process and role of a detailer is extremely important. Detailer must produce shop drawings, which are precisely showing exact cutting, drilling, and welding requirements for every member so that fabricator can fabricate and deliver to site perfectly finished steel members. Detailer also needs to develop erection drawings for erector with detailed information of placement of steel members, bolting and welding requirements, etc. Design drawing review. Detailer needs to review, study, architectural, structural, and on some jobs even MEP mechanical SAR electrical piping drawings. The basic intention of this review is to understand structural and architectural requirements defined on design drawings. Detailer also needs to refer project specifications. He should also precisely know AISC, AWS specifications, and fabricators detailing standards. He is then in a position to transform the design data into fabrication drawings for a fabricator and erection drawings for an erector. Design drawings are categorized into 5 key parts: architectural, structural, MEP, as-built, equipment drawings. Each part plays a vital role in ensuring accurate planning, construction, and documentation of a project. Project data. While reviewing design drawings, detailer needs to generate project-specific data which will cover all the critical requirements and will act like guidelines for project execution. Any missing or conflicting information on design drawings need to be verified with respective party, architect, structural engineer, MEP engineer, etc. This process is called raising RFIs. Working with digital platform, detailer may work in one of the 2 different frameworks. One is 3D, 3-dimensional model, and the other is 2D, 2-dimensional drawing. How to build the project in digital/graphical format. Presently, there are multiple softwares which can be used to build 3D model of the structure and then prepare 2D shop drawings as well as erection drawings. Quality checks. All the shop and erection drawings produced by detailer must be thoroughly checked for its correctness before submitting it for EOR approval process, EOR, engineer of the records, and after EOR's approval while submitting for fabrication and erection. Changes/revisions. Any design changes per revised design drawings received during execution of project, or any changes received as engineer's comments on drawings submitted for approval need to be implemented precisely and tracked.